All right, in this lesson, we will be reviewing sections 11.1 to 11.4 on basic probability for the most part, what's in here. And then you'll take a quiz on the same sections and then no new assignment. So it's just going to be a bunch of random questions mixed together. I'm going to throw them at you. This chapter, honestly, there's a lot of different topics. None of them individually are that hard, but it's hard to remember what to do in each situation. So in general, there are formulas and stuff, but I strongly encourage you to rely on just sort of like what makes sense, right? And that'll be actually true on our first question here. A buddy of mine in college named Scott, he would paint these tiny little figurines. I don't know if he used them for board games or what, but he enjoyed painting these things. So, anyways, I have 5 of them. Scott has 7. How many more ways? Let's say we're gonna have a giant battle. How many more ways can Scott order his figurines than me? Right. So your hint here is this order is the keyword. So pause the video, give it a shot. I'd do that on pretty much all the questions. All right, so honestly, what I would just think of is like, here's 5 spots for my figurines. Okay, and I would just think, okay, how many different figurines do I have to pick from when I put this first one down? Well, I got 5 I can pick from. Okay, and then from there, the next spot, I only have 4 to pick from, 3, 2, and then when I get to the end, I just put the last figurine in. Okay, so my total choices would be this times this times this times this. So it's basically going to be 5 factorial. Okay, and you could also do, that's why I highlighted order, is this would be a permutations question and you're 5 pick 5. Right, there's 5 total and you're picking all 5 of them. Okay, so however you want to do it, do one of those on your calculator and you get an answer of, let's see, I'm going to do 5 and then math and go over to probability. And here's the P key and the exclamation point if you want to do it that way. So 5P5, and we get 120 different ways. All right, and so more ways than I've just got to do for Scott, and his would be similar setup, except it would be 7. So I'm going to do 7 factorial, or again, 7P7, either one. Let's do factorial once just so you can see that. Okay, and his is going to be quite a bit more, 5,040. Okay, and how many more ways? Then we just subtract those two. So do 5,040 minus 120, and that would get us, looks like 4,920 more ways for him to line up his figurines than me. All right, so these are questions I use in class, so I know this is not a actual class, so you can think about these if you want, but the math question is down here. So we have 1 through 7 equally likely. What is the probability you spin an even number on the first try and an odd number on the second try? All right, so pause the video. Here's your keyword. Okay, so I want to spin, this is an and, so we're going to multiply them together. So an even on the first try, right? If I look at my evens, I got 1, 2, 3. So I have a 3/7 chance of getting an even on the first one, and then an odd would be all the other ones, which would be 4/7. And remember for and, right, I have to multiply these together, right? So to get both of these, my probability is going to be smaller than the original 2. In this case, 12 out of 49. All right, of getting both of those things happening would be 3/7 times 4/7. Okay, an OR probability. So we've got a fair-sided die, numbers 1 through 10, so I have to get either an even number or a prime number, right? Note that 2 is prime, but 1 is not. Prime means it has exactly 2 factors, 1 in itself. So 1 only has 1 factor, hence it's not prime. All right, so hopefully you've had a chance to try it. So with an OR, remember the way we do OR is you do the probability in this case of being even plus the probability that it's prime, because I can be either one of those, but then I have to minus the overlap, right? And if you want to do the actual thing, it's both prime and even, right? I just kind of do the overlap in my head here. So again, this is to me as I do what makes sense. So Like if I highlight the even ones here for a second, that would be 2, 4, 6, 8, and 10. So that would be even is 5 out of 10. And then prime ones would be 2, 3, 5, 7, and then 9 is not prime because it has an additional factor of 3. So prime would be 1, 2, 3, 4 out of 10. All right, but then we've got to look that this 2 got counted twice. I don't think any of the other ones did, but that 2 got counted twice. So we got to minus it off because it was an overlap. So our overall probability would be 9 minus 1, 8 out of 10, or 80%. Okay, and if you look at this, it kind of makes sense, right? Out of all the numbers, all of them are circled except 1 and 9. So our chances that we're either even or prime is all the other ones 8 out of 10. So you can almost just see it visually, right? And so again, I think it's good to do what makes sense and kind of think through it that way, even though technically we kind of used a formula here. But to me, the formula made sense. If it can be either one of these, you would add each one together individually, and then you have to minus this because it got counted twice. All right. Mutually exclusive. See if you can remember what that is, and then we want to find x or y. So it's another or probability. Okay, so the formula again, we here, if it's x or y, we do the probability of x plus the probability of y. Sorry, I got a lowercase x there. But then we want to minus the overlap, which would be when both x and y are true, right? But on this particular example, that's where this mutually exclusive comes in. Mutually exclusive means they can never happen together, which means the overlap is just 0. Okay, so our answer to this is I'd have to do just add them together. My probability of x plus my probability of y, and then I subtract nothing because there is no overlap. Okay, so our answer here is just you have a 38% chance of either one of those happening. All right, so this is an area probability, and it's clearly not drawn to scale. This is just 2, and then this whole radius is 10, meaning we have like, it's not apparent, this would be additional 8 inches out. So sorry, it's not drawn to scale. We just have to use your imagination. So pause the video and see if you can, it's landing, it doesn't say randomly, but it's going to land randomly in this dartboard. What is the probability we're in the green ring? Pause the video, give it a shot. All right, I redo the picture because it was driving me nuts so much. So to do this probability, I want to find the chances probability we end up in the green circle. That's favorable. Sorry, I'm doing this wrong. So I just want to do the chances, the area for the green over the total area. Okay, so the area for the green, remember area is just pi r squared. So I'm going to do pi times 2 squared, that's the green. Okay, so my green area is 4 pi. Okay, and then the total area would be this whole thing. So it would be the 10, the radius of 10, right? Because the whole thing has radius 10, so it would be pi times 10 squared, which would be 100 pi. Okay, so the chance that I hit the green would be 4 pi green out of 100 total. So if we simplify that, sorry, I ran out of space down there, but if we simplify it, the pi's would cancel, and we just have 4 out of 100, which is a nice percent, right? Percent just means out of 100. So we basically have a 4% chance of randomly hitting the green. Okay, and kind of interestingly here, you know, if I think sometimes you have to do like the yellow part of this, and so, you know, once we have this, it's actually kind of intuitive. You can, what would be an easy way, right? If it's landing in the circle and there's a 4% chance it hits the green, what would be the yellow? Okay, and so the answer to that is just the other percent, right? There's a 100% chance it'll land somewhere in here. So if 4% green, then the chance to hit the yellow would be 96%. So that'd be kind of a interesting follow-up. An easy way to figure out the yellow is once you know the green. Yellow is just the other percent. So I know this one just said green, but I thought it'd be an interesting follow-up question. Okay, another or probability, clubs or face card. Pause the video. Okay, so for the or, again, if it can be either one, I'm going to do the probability that I'm a club plus the probability that I'm a face card, but then I got to minus the overlap. Okay, and we'll see that visually here in a second. So my clubs, I'll try to highlight them here. Clubs are these little flower thingies, right? And there are 13 out of 52 cards that are clubs. Okay, and then my face cards are all these ones right here. So that's 12 out of 52. Sorry, I'm having a problem making the 52 there. And then the overlap would be these four right here that are both clubs and face cards. So they got counted twice, so we subtract them off. So our chances here would be 13 plus 12, 25 minus 3. So we'd have a 22 out of 52 chance if I just drew a card that it would either get a club or a face card. And obviously we could reduce this, right? It'd be around 40%, but we could certainly reduce it to 11 over 26 or whatever it is. Okay, yeah, so this is a kind of a tricky one. So we want to get a club card and then another club card, and we don't replace the first one. So pause the video and see if you can make sense of this. This one's kind of tricky. Try to make it fit a little better. Okay, so this is an and, so we want to multiply the two probabilities together because it's club and club, right? So it's club and a second club. So on the first club, there's 13 out of 52 that are clubs. Okay, but on the second one, it's a dependent event, right? Because we're not replacing it. So that means there's only 12 clubs left out of 51 total cards, right? So the chances of getting a club and a club, remember you just multiply them together on an and that would be our chances. Right, so we get 156 out of 2,652, and that's about 6%. So your chances of getting one club and another club is only 6%. All right, tossing two coins, and remember, experimental probability is what actually happens, not what should happen in theory, but what actually happened. So we have 50 simulations and probability of getting one head and one tail in any order. Pause the video. Right, so here's your one head and one tail cases. So that's 27 total out of 50. Right, and that's actually pretty close to the theoretical. I think theoretical probability here is a 50% chance. And so we ended up with pretty close to 50%, a little bit over 50%. In other words, we got lucky. All right, so here's an OR probability, and they are not mutually exclusive here. Pause the video. So for an OR, you add them together and then minus the overlap, okay? And here's your overlap right there. So I would have 1/9 plus 7/9, and then I would minus off 2/9. So that would be 8/9 minus 2/9. That would be 6/9 chance in this particular example. Okay, I got a few more questions that'll probably be really good for you to do preparing, but I'm running low on time, so I'm going to make a second video.